Hello everyone, and welcome back to another Unit 2 video. Today we're covering our second and final section of this unit, covering partitioning a segment. The best way to teach this is to just jump right in, so we're going to go ahead and go right into an example here. So I have this example that says find the coordinates of point P that lies along the segment from A at the point -4, 0 to B at the point 6, 5. And partitions the segment in the ratio of 1 to 4. All right, so I already pre-drew my segments in for this lesson, so you might want to take a minute and go ahead and plot those points. When you are reading a question like this and it says that it is sectioned in a ratio of 1 to 4, that doesn't mean that there are 4 total sections. That means that there's actually 5 total sections. So you're splitting the line somewhere on here into a 1 to 4 ratio. So if there's a ratio 1 to 4 together, it's 5. So anytime it tells you that you have this ratio from 1 to 4, then the first thing you want to do is add the ratio pieces together. I'm going to change to basic color here, so I have 1 plus 4 is equal to 5. So that means that we're really dividing into 5 sections, and then once we have our sections, we'll be able to go ahead and find that ratio. So I'm going to start with my, on the line, I'm going to start with my y direction, and I need to find how far I travel from one y point to the other y point. So I'm going to draw on my graph, I have this distance that we're traveling from here to there, and there's 1, 2, 3, 4, 5 squares. So I've traveled 5 down, and I am dividing my height by that amount that we're cutting. So I have 5 divided by 5, which is equal to 1. All right, we'll come back to that. Now I'm going to go ahead and look at my horizontal direction. So I travel from A to B horizontally this many spaces. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I traveled a distance of 10. I'm also going to divide my horizontal distance by the amount of sections that I want to have, which is 5. So I have 10 divided by 5, which is equal to 2. So now where these numbers come in play is that this is telling you that every over 2, up 1 distance you travel, over 2, up 1, that is where you are going to have a cut in your line segment. So I'm going to switch back over to this blue here a second, and I'm going to go over 2, up 1, and I'm going to put a point there. From that point, I'm going to continue over 2, up 1, and put a point on that line. Over 2, up 1, put a point on that intersection. Over 2, up 1. Over 2, up 1. And I land right on this point B. If you did this correctly, you will land on your end point. Now, as I'm looking at this, I'm noticing that there's 1, 2, 3, 4 points that I put on the line. But we're not looking at points, we're looking at parts of the segment. And if you count the parts of the segment, we have 1, 2, 3, 4, 5 parts of our segment. So now I have 5 parts of the segment. I can split it into a ratio of 1 to 4 because each part of this segment is not only split, but it's also congruent. So if I'm going from A to B, that means I'm starting at A and I'm going left to right because I'm going from A to B, ratio of 1 to 4. That means that I need to split from A to B in a ratio of 1 to 4. So I kept 1 segment for A and 4 segments for B, which means that the point P that I was looking for that split this line into 1 to 4 is this point right here. So that is point P, and I'm going to erase my segment lengths there, and just point P right there. So P is at the point -2, +1. All right, let's go ahead and look at another example. So we have find the coordinates of point P that lies along the segment below from X to Y and partitions the segment in the ratio of 1 to 2. All right, so I have this segment that's drawn on here. You're gonna have to add that. My X is at the point -1, and my Y is at the point 5, 1. Now I'm trying to split this into the ratio of 1 to 2. So I'm gonna start by adding my ratio together. So 1 plus 2 is equal to 3. So I'm trying to split this segment into 3 sections. So now I'm going to go ahead and I'm going to grab my color that I used for my vertical distance, and I'm going to figure out how far down we traveled. And that's 1, 2, 3, 4, 5, 6 that we've traveled. Just ignore that bell. And then I'm going to find the distance that I traveled in the X direction, the horizontal direction. So I go from where I dropped off over to my Y point, and I went 1, 2, 3, 4, 5, 6 there as well. I'm going to drop that down a little bit so you can see it. So this is 6. All right, and if that arrow helps, remember that that is 6 that we're talking about. All right, now I'm going to go ahead and figure out exactly how far that I am traveling in each direction. So I'm going to do that by taking the total distance of squares and divide it by the number of sections we want. So I want 3 sections, so I'm going to divide that 6 by 3. So 6 divided by 3 is equal to 2. And 6 divided by 3 is still equal to 2. So I'm going down 2, right 2, down 2, over 2. Right there is my first point. Down 2, over 2. Got another one right there. Down 2, over 2. I'm on my end point, so I have done this correctly. I got to where I wanted to be. So I have 1, 2, 3 sections, which is what I wanted. Now it says that we're partitioning from X to Y in the ratio 1 to 2. So I need 1 on the left and 2 on the right. So my point P has to be the one that splits me into 1 versus 2. So this right here is my point P. And I can go ahead and say that P is at 1, 5. All right, let's look at one more example. This next example is going to have a slight change in how it is written. It says here to find the coordinates of point P that lie along the segment from R to S and is 1/4 the distance from R to S. Okay, here's where it gets tricky. So before we were talking about a ratio where we had 1 to 4, so you really wanted 5 total sections. Now we have this fraction that says that it is 1 out of 4 total parts. In fact, I think it'll be helpful to write that down. So I have 1 out of 4 total parts. If I want 4 total parts, that means that I already know how many sections on my segment I want. So I don't have to add those together because it tells me that I want 4 of them. So now I'm going to go ahead and start by finding my horizontal and vertical distances again. So I'm traveling from R to S and I'm going upward, and I go from here to there. 1, 2, 3, 4, 5, 6, 7, 8. Traveled 8, and now I want my horizontal distance, and I travel this way, and I traveled 1, 2, 3, 4, 5, 6, 7, 8 that way as well. And both of these are going to be split by the number of sections that I want. And remember, It's 1 out of 4 total parts, so I want 4 sections. So I'm going to divide both the horizontal and vertical distances by 4. Both of them happen to be 8. 8 divided by 4 is equal to 2. So I am traveling over 2, up 2. Over 2, up 2. Over 2, up 2. Over 2, up 2. And now I should have 1, 2, 3, 4 total parts. Now that I have 4 total parts, and it says that it is 1/4, that means from R to S, we're starting with 1 out of the 4 sections. So we're really splitting into a ratio of 1 to 3. So my first section, this 1 that I have is right here because I want just that one length. I've counted 1 segment length, which means that my point P must be at this point here because that is what splits me into 1 out of the total of 4. So P is at the coordinate -4, -1. All right, but what if we said that we wanted 1/4 the distance from S to R, not R to S? Well, then it's starting up at S. So we're going to count that 1 point, and then we should have 1 and 3 for the rest. So instead of P being at this point here, P would be at the point that's up here. So we'd be at the point up 3 over none. So we went 0, 3, because your x comes first. All right, so that's how we partition a segment. Now we're going to go ahead and look at this in a problem that involves a circle. All right, so here we have this problem that says a circle in the coordinate plane has a diameter with endpoints A at -4, 2 and B at 4, -6. Find the center of the circle, then find its radius. So if I'm trying to find its radius, that means that I'm trying to find my midpoint of this line, or I'm trying to split this into 2 parts. So I have 2 parts that I want on my line. So we have 2 options. We can either partition a segment and find 2 parts. So count, divide, or I can use my midpoint formula. I think my midpoint formula might be a little bit quicker in this problem, so that's what I'm going to start with. So I have M, or C, for the center point, I guess is what we'll call it. So center is going to equal C, so I have C is equal to my midpoint formula, my x1 plus x2, -4 plus 4 divided by 2, my y1 plus y2, so I have positive 2 plus -6 divided by 2. And I'm going to simplify that. -4 plus 4 is equal to 0. 0 over 2 is still 0. 2 plus -6 is equal to -4. -4 divided by 2 is equal to -2. So my center is at this point here, 0, -2. So C is equal to 0, -2. That's my center. I'm going to go ahead and put that on my graph here. So now I have A to B with my center of C. Now I want to find the radius, which is from A to C or from B to C. Either one works. To find my radius, I'm going to use my distance formula. So the distance from A to C is what we would call the radius. So in my formula, I'm going to say that R is equal to the square root of, now remembering my distance formula, x1 minus x2 squared. So I have -4 minus 0 squared plus y1, which is 2, minus y2, which is -2 squared. I'm going to go ahead and simplify underneath the square root. So I have negative 4 minus 0, which is negative 4. Negative 4 squared is equal to 16. So I have 16 plus 2 minus negative 2. When you are subtracting a negative, this becomes a positive. They combine to become a positive. So I really have 2 plus 2. So I have 4 squared. So 4 squared is 16. So I have another 16. 16 plus 16 is equal to 32. So now I have the square root of 32, which is equal to approximately 5.66. And that is rounded. Alright, so now that we have found both the center point and the radius, we're going to move on to this part of the problem down here. It says, for the previous problem, determine if the point 4, 2 lies on the circle. Explain why or why not. Alright, so we can solve this in two different ways. Well, at least two different ways. So we're going to go ahead and start with the distance formula again, because if the distance between this point and the center point is the same as the radius, then that means that this has to be on the circle because it is exactly the same distance away from that midpoint. So I have my radius that I'm looking for, and this should be the answer again. But I'm using my center point and this point this time. So I have that D is equal to the square root of x1, which is 4, minus x2, which is 0, plus 2 minus negative 2 squared. Well, wait a second. This formula is exactly the same as what I just solved up here for my radius. So I already know that's going to work out. I don't need to simplify this any further because I already showed that work on this page. So I can say that D is approximately equal to 5.66, and because D is the same, that means that it is on the circle. So to put that into words, D equals the radius. So the point 4, 2 must lie on the circle. Alright, so that's one method. The other method is if we were to look at this and follow the slope of the line and plot the point 4, 2, then it should end up being right on the line. So that would be the partitioning as segment method. So you would have been finding the slope and traveling up and over. We're not going to go through that method. This is a method that works and follows with what we previously have done in the last couple lessons. All right, this is where we're going to go ahead and end for our section and for our unit. We'll pick back up in our next video with our Unit 3, which is our first proofs unit of the year.